after having some elementary concept of probability, now it is time to talk the distribution. Before going to the Maxwell's distribution of molecular speeds. Distribution is the division of a group of things into classes depending on with respect to certain properties. Say suppose if we have the 1000 balls of different masses, then we can divide the 1000 balls in several boxes according to their mass, and this is called the mass distribution of these balls. Similarly, you see, if we consider the population in a country, the population having the different ages, we may like to know how many people having the age from 0 to 5 years, 5 to 10 years, 10 to 15 years, 15 to 20 years, 20 to 25 years. Then it will be the age distribution, means division of the people with respect to their age, on the property of their age, considering their age. Similarly, in a class, if we consider how many students are having the marks in a paper of 100 marks in an examination, then we can divide the students or examinees having the mark 0 to 10, 10 to 20, 20 to 30, 30 to 50, and in 10 classes. Total in 10 classes. So it is the marks distribution among the students. Similarly, we can call the height distribution of these people in a country, or the wealth distribution among the people in a country, and so on. So you can notice that whenever we are talking this distribution, we are putting some range. Say in case of the age 0 to 5 years, 5 to 10 years, means interval or width of the interval, interval, in this case the 5 years, 0 to 5 years, 5 to 10 years, etc. This is the width. Or in case of these marks obtained by the students in an examination, the interval is taken at 10 marks. So this interval or the range or the width of the interval is very important for making a distribution of a group of things into their respective classes depending on certain properties. If the range is very wide, if the width of interval is very wide, say suppose if we take in case of this age distribution 100 years, if we take this interval 100 years, range 100 years, then all the people will come up in a single class and there will be no distribution. So this or in case of the marks obtained by the students in a paper of 100 marks, if we take this range 0 to 100 marks, then all the students will be in a single group, and there will be no distribution. Distribution is impossible. So the range or the interval must not be very high. Must not be very high. Then it is not possible to divide the group of things into their classes. Again, if we take this range very small, too small, say one day, in the case of age distribution, if we take this interval 1 day, means 0 to 1, 0 to 1 day, 1 day to 2 day, 2 day to 3 day, 3 day to 4 day. Then in a large number of population in a country, it is very difficult to make a chart of distribution, how many people are having the age 0 to 1 day, 1 to 2 days, 2 to 3 days, etc. Even if we consider the 10 people in a small group, 10 people, and if we consider the interval or the range 1 day, then each class will contain the one person only, and some classes will remain vacant. No person will come up within that range. So it is very interesting to make a choice of the interval, width of the interval. It should not be very high, or it should not be very small, to make a significant aspect of this distribution. Significant aspect, or say meaningful aspect of this distribution, which will give you the total picture of the properties in a system. This distribution is very important to make average value, to make the average value of this property. The property, you could take this average if you know the distribution of these properties among the group of things. Say, a very simple case. You have already done such type of calculations in class 5 or 6. Say average of this age of boys. Calculate the average age of the boys. Say I am writing a chart, distribution chart. Distribution chart. Say it is the distribution of age. It is the number of boys, and it is the age of boys. Two columns are there. It is the chart. It is the distribution chart. So here, suppose you have two students having the two boys having the chart just 6 years. Two boys, each of them having the age 6 years, and 3 boys having the age, say, 7 years, and say 5 boys having the age 8 years, and say 3 boys having the age 9 years, and 2 boys having the age 10 years. Each of having the 10 years. So this is the age distribution of these boys, and total number of boys Total number of boys 15. 15. So if you know this distribution, here the years have been taken in full numbers, not months and days are taken to make it simplify. And what will be the average age of this group of boys, group of 15 boys? Then it will be this average age. Age is represented by A. So average age is represented by A bar. So A bar will be equal to weighted sum of the years divided by the total number of boys. Weighted sum of the years means 2 into 6 plus 3 into 7 plus 5 into 8 plus 3 into 9 and 2 into 10 and divide by total number of boys, and it is 15. If you do these calculations, then you will see the 8 years. 8 years is the average value, and you have done such type of calculations in your lower classes. That means each of the boys have been taken the average age 8 years, irrespective of the number. Actually, it is the 8 years is the balancing age of this group, balancing age, and this we can write in a different way in terms of this probability. In terms of probability, we can write 2 by 50 into 6 plus 3 by 50 into 7 plus 5 by 50 into 8 plus 3 by 50 into 9 and 2 by 50 into 2 by 50 into 10. And these are, say, 2 is the favorable event, favorable number of students having the age 6, and it is the total number of boys. So this one gives you the probability of a boy. This one is the term within the bracket will give you the probability of a boy to have the age 6 years. This 3 by 50, this is also the probability of a boy to have the age 7. This is the probability for the boy to have the age 8, and this is 9 and this is 10. So you can write this term in terms of this probability, and you know it means that the 6 years of age coming two types. 2 is the outcome of the age 6. 3 is the outcome of the age 7. 5 is the outcome of this age 8. 3 is the outcome of this age 9. 2 is the outcome of this 10, and total number of this outcome is 15. So you can write in general, say, and this is also 8 years. 8 years. You can P1 and A1, you can write. P1 is the probability of a boy to have this age A1, and this one is called P2 and A2. P2 is the probability of a boy to have this age A2 plus P3 A3 plus P4 A4 plus P5 A5, and you can write the summation of Pi or Pj and Aj. Pj is the probability of a boy to have this age Ai. This calculation we like to make a general way. We can make with this statement, these calculations we can make the general fashion of a property X. Suppose X is the property. Suppose in an experiment, for property X may be any property. Say X may be the age, X may be the height, X may be the wealth, X may be the marks, etc. So suppose for this property X, the x1 value, outcome of this x1 value is n1 times. Means n1 times the x1 outcome is coming up in an experiment. Say if you do this OR analysis, that's several experiments of the same OR you are doing, then this value, this result, this percentage of this say suppose metal in the ore coming n1 times. In a similar way, say x2, the value coming n2 times. This is the outcome. This is the outcome of this property, and this is the times of coming that outcome property. And this is x3, suppose n3, and so on. And xi coming n9 times. X is any property. Say x may also be the age of these boys. So in this case, the average value of x, weighted sum of this property divided by the total number of outcomes. Total number of outcomes, how much? n1 plus n2 plus n3 plus dot ni. So here the x1 into, or you can say n1 x1, the value of that property coming n1 times, plus n2 times coming the property x2, plus n3 times the value of this property is x3, plus ni and x, and divided by n1 plus n2 plus n3 plus ni. So this you can write here. This value, suppose n, total number of times coming is equal to, suppose n. So this is n1 by n, we can write, and into x1. n1 is the number of times coming this, number of outcomes coming of this value x1. So n1 by n, this is favorable event, this is the total event, this is the probability. This term within the bracket is the probability of the system having the value x1, plus n2 by n. into x2 plus n3 by n x3 plus dot ni divided by n into xi. So this is the probability of the outcome x1, and this is the probability for the outcome x2. This is the probability for this outcome x3 appearing x3, and this is the probability of having this value xi. So this one you can write this p1 x1. p1 is the probability to have the outcome x1, plus this one is the p2 x2 plus p3 x3 plus p4 plus dot pi xi, and you can write a summation of pj xj. pj is the probability of appearing the property value xj, and it is the summation. This calculations is valid whenever we are considering the discrete values, no range, no width of the intervals, discrete. And if we use this continuous, if we use the continuous properties, whenever the property is changing continuously, like the speed of the molecules or the age of the persons in a country or the height, in this case, whenever the property is changing continuously, not a discrete way like this, the method of averaging will be a little bit different. Discrete and the continuous, these two I can show you that suppose you are taking 1 gram or 10 grams sugar crystals. Each sugar crystal is discrete from this other, independent entity. But if you take this 10 gram water in a container, then water remains in a continuous way, no discrete way. So this is the discrete values, x1, x2, x3, x4, xi. These are the discrete one. Now, whenever the property changes continuously, suppose x, property x changes continuously. Then this x bar, or the average value of x, will be, the summation will be replaced by integration. You know, in your integral calculus, whenever the property changes continuously, this summation is replaced by integration. And integration, this is also summation, s, and summation all values of x. And here the property x, and in this case the fx dx. This fx dx, pj is replaced by fx dx. Fx dx is the probability to appear the property x, and having the range of x, all possible values of x are permissible in this case of integration. So this px is equal to fx and dx. dx is the probability of having the value x within the range x to x plus dx, and dx is an infinitesimally small, so that the property is assumed to be taken changing continuously. So this fx is called the distribution function, and this is called the distribution function. Distribution function, or sometimes also called probability density function. So this distribution function fx is equal to px divided by dx. It means that fx is the distribution function, and distribution function is the probability of the property of appearing this property x within unit range at x. Whenever it is divided by dx, range is divided, so it becomes a unit range. So this fx, you can write this 1 by a and dnx divided by dx. dnx is the favorable event. This number of outcomes of x, and dx is the range of this property, and n is the total number of outcomes. So fx is equal to this. Similarly, if we give you some concrete values, say age distribution, the height, or say age distribution, say a, then in this case it will be integration, and age is 0 to infinity, theoretically never negative, age will not be negative, and here the property this age, and here this fa and ba. Similarly, height, average height, you can write 0 to infinity, and here h and fh and dh. dh, and fh dh is the probability of a person to have the height, have the age, have the height in the unit range at h. Means small, within a small height range dh at h. And suppose if we consider, say, if we consider the one dimensional velocity, say x dimensional velocity, u, average velocity, average x component velocity, and in this case you can write this integration, and range would be minus infinity to plus infinity, means the x component velocity can range minus infinity to plus infinity, and here u and f du, fu and du, and fu is the distribution of this x component velocity, distribution function of this x component velocity, du the range. So this one is the probability. Probability means it is the this FUDU is the probability of a molecule to have the velocity, x component velocity, u within the range du. But whenever we shall say, we shall talk fu, it is the distribution function, then in this case, it is the probability of a molecule to have the x component velocity within the range du at u. So these are the distribution probability and distribution function. We can cite some example. Say in a group of people, suppose the FH equal to DNH divided by DH and 1 by N. This is the FH. This is the probability DNH by N. This is the number of people having the age H, having the height H, and divided it is the total number of population. So it is the probability, and this probability is the probability of a person to have this height H to H plus DH. But whenever you are considering the FH, then it is the probability of a person to have this height H within unit range at H. Say F 180 centimeter equal to 0.12 centimeter inverse. Distribution function having this unit of H. This is number, this is number, this is number, this is number, and this is the height centimeter inverse. So it means that in that group of people, the probability of a person to have this height 180 centimeter within the range 1 centimeter is 12%. Is 12%. Or you can say if you choose the randomly in a group of people, then that person then 100 among the 100 persons, only the 12 persons will have the height 180 to 181. 180 to 181 centimeter. This is the 0.12%. So if we consider the F 200 centimeter, then 200 centimeter, a large height of a person, so it may be 0.01 centimeter inverse. That means the probability of a person to have this height 200 to 201 centimeter is only 1%. So the probability differs on this at which point we are considering, which height we are considering, whether it is 180 or 200 or say 100 and so on. In case of the continuous property, whenever the property changes continuously, it will also obey the multiplicative property of this probability. Suppose the probability of the value of of the property X within range dx at x equal to px. That means px is the probability of a property, of a certain property x within the range dx at x value, x at this x. Similarly, probability of this of another property, another independent property, say y within range dy at y equal to py, and this x property and y property is assumed to be independent to each other, unrelated. As we have seen in my last class, in case of a probability, the left-handedness, that property is not connected with this male person, or it is not the characteristic property of this male person only. So here also x and y, these are the independent. So in this case, the probability of a system to have this property x and y within the range dx and dy equal to px into py. So you can write this fx and dx into py into dy, or you can write fx, fy and dx and dy, multiplicative property. In case of continuous properties also, and pxy is the probability to have the values simultaneously, x within the range dx, y within the range dy, at this value x and the value y equal to this one. So this is in a very small way, the distribution has been discussed. In my next class, distribution is always there, you know. In a class, you have seen several sections are there. Suppose in a class there are 4 sections. Okay? Then sections are based on the marks obtained in a certain examination. Say 75 to 100, the students having the scoring this mark is taken in section A, and 50 to 75 in group in section B, and 25 to 50 section C, and 0 to 25 in group D. So distribution is always there. Distribution of the wealth of a property in a family always been common discussion. So distribution I shall show you more in a more elaborate way whenever we shall discuss the Maxwell distribution of molecular speeds. This is all about the today's lecture. In my next class, I'll go to the main aspect, Maxwell's distribution of molecular speeds. But it is to be said that it is not very easy way in a YouTube lecture to give the derivation of this Maxwell's distribution. It will be very much lengthy. So in a very brief way, we shall discuss, we shall give you the concept of the Maxwell distribution of molecular speeds. So this is all about today's class. Thank you for watching this video, and I hope you will also watch my next video. next video.